I think there has been no lights and the speakers did not charge. So let's keep quiet if you want to be a part of this class. But if you don't want to be a part of the class, you can excuse your way, let me go. So let's keep quiet. We don't have much time. So yesterday I defined oxidation and reduction. So oxidation is the addition of oxygen, while reduction is the removal of oxygen. And I told you that they can ask you of a substance or a species that is undergoing oxidation and not. Then we started some basic calculations. I think that was where we stopped yesterday. So let's write the next rule. The next rule. Right. The algebraic sum of all the oxidation states. The algebraic sum of all the oxidation states of all of the elements in an ionic compound. The algebraic sum of all the oxidation states of all the elements in an ionic compound is equal to the charge. Is equal to the charge carried by the ion. The algebraic sum of all the oxidation states of all the elements in an ionic compound. In an ionic compound. So guys, find where to sit so that you don't block the road for heat and get to exchange. So the algebraic sum of all the oxidation number of all the elements in an ionic number must be equal to the charge. Is equal to the charge carried by the ion. Carried by the ion, e.g. So this is what we are saying. Question 1. Determine the oxidation number of the following underlying elements. Let's just do it this way. B2O5 minus. Number 2. Cr2 O72 minus. Number 3. MnO4 minus. Number 4. We are looking for chromium, vanadium, and manganese. K4. Is anybody calling on? So quickly, we have to calculate the oxidation states of all the underlying elements. And in those ions, we already said the algebraic sum of all of the oxidation states will be equal to the charge. That one we did yesterday. We said the algebraic sum of all of the oxidation states will be equal to 0. because they were neutral compounds. So it's the same thing for ions. When you sum all the oxidation states together, it will be equal to the charge carried by those ions. Is that taking? Some of you are still murmuring, and that's why you are allowing me to shout at the top of my lungs. As much as you keep quiet, even if I whisper, you will hear me. So you can see now that I'm not shouting. I can even feel that everybody can hear me. So please, let's keep quiet, except you have a question to ask. So, from what we have here, V2O5 minus, they said we should determine the oxidation states of vanadium there. So what do we do? Just the same way we have been doing it. Solution. Now, the one we are looking for, we call it X. And there are two of it. So we are going to have 2X plus 5 into, we said every time we have oxygen, it is always what? Minus 2. And that's going to be equal to the charge carried. That's the difference. The charge carried here is what? Is that taking? So we can now say 2x minus 10 is equal to minus 1. 2x is equal to minus 1 plus 10. And 2x is equal to 9. X is equal to 9 over 2. Normally, you are not supposed to have this. I just gave you that for you to just follow. You are not supposed to have a fraction. Is that taking? But when you get to a level later, there are fractions. But for now, you are not supposed to. So, the second one, can we do the second one? So, what's that going to be? 2x, Abi, plus 7 into minus 2 equals what? Obli, yo. 2x minus 14 equals minus 2. 2x is going to be minus 2 plus 2x is going to be, is that taking? X is going to be, so that's going to be heptachromate, what's it called? 6 ion. Heptachromate 6 ion. We put ion because it's an ionic compound.
It's not dichromate.
It's still dichromate. Are you there? Can you do the third one? Oh yeah, we still have a lot to learn. All these ones are still normal things that you can even use your eyes to look and you pick your answer if you get smart enough. So number 4 is just like the one we did yesterday too. What is the oxidation state of potassium? Normally, if you look at this guy, ordinarily looking at it, you can tell. If this one is plus 1, how many of it do you have? 4. That means this one is going to be plus 4. Then, in order for it to be balanced, all these ones are neutral. So this one will be 0, this one will be 0. And if this one is minus 1, then that's minus 2. Minus 2 plus 4, that's plus 2. For this one to have been plus 4, then this must have been plus 2. So the answer is plus 2. But what am I saying? Let's see. So from there now we say 4 to plus 1, right? Plus the one we are looking for, x. Plus 4 into 0. Plus 5 into 0. Plus 2 into minus 1 equals plus 4. Do you see what I've done? 4 into plus 1, that's for potassium, plus x, that's the one we are looking for, that's iron. Plus 4 into 0, because that is a neutral ligand. Then 5 into 0, another neutral ligand. Then we have 2 into minus 1, and we have plus 4. So summing everything up together, we have 4 plus x minus 2 is equal to plus 4, right? So we can say x minus 2 is equal to 0. Do you agree? X is equal to plus 2. So the oxidation state of iron here is what? Plus 2. It's plus 2. Can you solve the rest? I did class. Okay. How do you know neutral ligand? Okay. Someone say, how do we know they are neutral? They are neutral compound. It's the same question you asked that is written in the paper. When you get to transition elements, we have ligands. All these molecules that are joined to transition elements. Iron is a transition element. So these guys that are joined to transition elements, they are called ligands. Ligands. So those ones, there are now two types of ligands. We have what we call neutral ligand. Those are the ones that do not carry a charge. So we call them neutral ligand. If I have NH3, men and brethren, nitrogen is going to be -3. The total of hydrogen is going to be +3. -3 plus 3, 0. So the oxidation state is 0. You know, if I start summing this guy, everything will point to 0, Abby. That's what I'm trying to say. So for neutral ligands, they usually don't have oxidation states. So example is ammonia, H2O, CO, and so on. Then we have what we call negative ligands. Negative ligands are those ones that carry a negative charge. Then we have Cl minus, Abi, F minus, Br minus, Cn minus. Those are called negative ligands. So if you look at this place now, which one is my negative ligand? Br, Abi. So these ones are my neutral ligands. So neutral ligand means the oxidation state is 0 altogether. But if you want to write Br, you know it is Br minus. The 2 is just there. So now, and I told you too, when you are naming these complex compounds, whenever you are naming them, you start with the negative ligands. So those of you that want to know the short rules quickly, the rules to name them. When you are naming, so you will name the negative ligand first. When you are naming, then you name the neutral ligand. Then you now name the transition elements. That's the rule for those in the brackets. But when you have them like this, that there's something here, there's something here. If there's something here, you will name that one first. The metal is named first. Like in this situation now. And whatever is here is named last. Last element outside brackets. Outside brackets is named last. It's named last. I'll give you like 2 examples quickly for that. But that's not the purpose of this class. So we have a negative ligand when you are naming, followed by the neutral ligand, followed by the transition elements. Now if your neutral ligand is more than 1, just like what we have here now, we already have 2 of it. So in that case, we arrange them in alphabetical manner when you are naming them. So what do we have in this case? This is going to be, since this metal is present, you start with the metal. So it will be potassium dibromo. Anytime you have chlorofluorobromo, if it is iodine, it will be iodo. And this one is cyanide. So we call it cyano, hexacyano, pentacyano, and so on. So, but from what we have here, this is potassium dibromo, penta, aquo. But between Aqua and Amo. I think Amo should come first, Sabi. AM comes before AQ. So this is going to be potassium dibromo tetramethylpentacoferrate 2-ion. So that's potassium dibromo tetrahydropentacofferrate 2 ions. So that's the name. You name this one first. Potassium. How many bromine do we have here? Then that becomes dibromo. How many ammonia do we have here? That is what? Tetra. So that would be tetra. For water, you name water aqua. Aqua. Like aquarium. How many aquarium do we have? 5. So that's going to be penta aqua. Then you name it the Latin name, not iron but ferrate. So that would be ferrate 2. How did I know it's going to be 2? That's what I got here. Ferrate 2, then you put ion because it's carrying a charge. So that's the name. Potassium dibromo tetramethylpentacoferrate 2-ion. Some of you be saying that orúkọ ló mú to buy. Have you also checked some of your names? Olúwa fi mí sílé mi ò bọ́mọ lé. So let's move on. There are a lot to talk about. Can you solve this? Can you solve this? So let's move on to the next thing. Balancing of redox equation. No, let's talk about redox equation. Redox reaction. It's the same thing we have been doing, but in another format now. Can I rub the board? No. These days, I read with this time. I'll be looking at what is Oh yeah, can I love the ball now? Yeah. let's come back to class, please. Now, it's the same thing we have been talking about since morning. But before I start this, maybe I'll give you some equations and you are going to tell me. Now, a redox reaction is a type of reaction in which both reduction and oxidation occurs simultaneously. So it's a reaction that involves both reduction and oxidation. And both of them occur simultaneously. If a substance is undergoing reduction, the other is undergoing oxidation automatically. But that substance that is undergoing reduction, we usually call it oxidizing agents. Oxidizing agents. While the one undergoing oxidation is called reducing agents. So you need to pay attention from here now. And let attention pay you. A species that is undergoing reduction is called oxidizing agents, while the one undergoing oxidation is called reducing agents. I don't know what your purpose is. I just don't know. What's your goal in life? Eh? To talk and laugh. It's good, it's good. It's good. Because this life is full of trouble. So if your own goal in life is just to talk and laugh, provided you will never face trouble in your life, you will never complain. Laughter is good for your health. But baby bá wá pẹ́ lọ́la tó bá sunkún sí anybody lọ́rùn, baby bá pẹ́ ṣàmárẹ́rìn. Gbogbo nǹkan tó bá bẹ láyé wọ́n ṣàmárẹ́rìn jẹ́ kí bẹ́ẹ̀ máa dùn lọ. Bọ̀ ìwọ́n tó mọ̀ kó fẹ́ kébi pẹ́ lọ́la tètè máa kára mọ́ṣẹ́ báyìí. Ó máa kára mọ́. Can we move on, please? We don't have time to waste. As much as we can shout, this class is not for everybody. We always know that. At least this is my 16 years now since I've been teaching. So I've taught for good 16 years. I started in 2010. So however it is, it now depends on you. There is no way. I've taught a class before that. There might be a lot of people that gain admission. The class was even many. And sometimes when I enter the class, some people like this, they will just face themselves. And they present to a job. There's one girl who told me about from beginning of class to the end of class, she will eat. So whatever you are saying, and there were two people always at the front, like this. They were friends. And as I'm teaching, they are asking questions, they are always being pushed and up. And the two of them, but she pushed to Kawito. At the end, they still even had to pay for private class during those periods. And at the end, one had 320, one had 307 in the same class that nobody scored above 200 or something. So, and 4 years after, I saw one of them in class. That I now saw her, she went to register for JAMB. And I was like, what happened? You did not write JAMB that year. You may not share your bond back. Everybody back, not about 2 times. When it's time, everybody will know. It's a different thing in facing challenges. But when it's time to have sense, they won't even teach you. You will have it by force. So let's go on. So the class is not necessarily for everybody. But I want to see, they should make use of it. I want to they might gain admission. They might even gain admission before you go to go. Yes, they might even gain admission before you go to come, but I can bet it. I can bet it. But they might not tell you. When they get to school, they will now tell you back. So, but please, keep doing your best. Oxidizing agents, reduction. Reducing agents, oxidation. And we said something that oxidation is defined as loss of electron, while reduction is gain of electron. So electron loss, you remember what I told you yesterday already, Abby? So the electron loss by one is gained by the other. The one that undergoes oxidation is losing electron. The one that undergoes reduction is gaining electron. Abby? Oxidation is loss of electron, reduction is gain of electron. So now, let's look at what we are saying here. From the stories I told you yesterday, let me repeat this guy. Now we are not using oxygen. We are just using the atoms. So from what we have here, all of you can tell which one is undergoing oxidation, Abby. Yes. But we are not looking at it in terms of oxygen now. Let us determine their oxidation states. This is going to be 0, Abby. Yes. I think that's one of the things I forgot to tell you in the rule. Whenever an element is on its own, the oxidation state is usually 0. When an element is not in combination with another element, the oxidation state is usually what? 0. For this one, the oxidation state is what? +2, and this is what? -2. This is going to be +2, this is going to be -2. This is on its own, so it's going to be 0. So now if we look at this, they can ask you, is this reaction a redox reaction or not? Now, is it a redox reaction or not? It is a redox reaction. Listen, how do you know if a reaction is a redox reaction? It is a redox reaction. It's a change when there is change in oxidation states. A reaction is a redox reaction when there is change in oxidation states. So look at zinc here. It changes oxidation state. So they can ask you to calculate the change in oxidation state. This is 0 here. What's this one? +2. So you are going from where? From 0 to +2. So something has changed. Provided you see that, then that is a redox reaction. Let me give you another example. NaCl, or provided NaOH plus H2SO4 to give Na2SO4 plus H2O. Now, they now ask you in your exam that is this a redox reaction? You are going to check. Most times when you see one element on its own, actually, it's a redox reaction. Just one element on its own, it's a redox reaction. This generation, phone is very useful to all of you. But as much as phone is useful to all of you, many of you will use that same phone to ruin your lives. That's why some of us, maybe we should appreciate God that when we gain admission to university, we never had phone. So along the way, we had phones. And let me tell you one thing. The very first person to give me laptop in this life, when the person gave me laptop like this, the person gave me modem. Modem then, because then there was no all this Wi-Fi connectivity and all. No hotspot that you are using now. Then they used to buy modem. MTN will sell the modem. Then they will insert SIM card. Then they will subscribe on it and insert it on the system. That's what they used to browse at home if you are not going to cafe. So when that person wanted to travel abroad, the person gave me a laptop and gave me a modem. And the person told me, because the person was part of the person that used to help my life little by little then. I was working for the person. He was a student of law in OAU then. And when I was working for the person, you post it out. I've already. So when I was working for the person, this person actually, I was helping him to stay with something, so I delivered to him. I give him money and everything. And at a point, if he wants to wash his clothes, he might ask me to go and give dry cleaner, but I need money. I'll tell him, I'll go and wash it. So the money to give dry cleaner, that's what me I will use to survive. And a whole lot of times it continues. His ATM card was always with me. There's nothing in it. It's just a cup. I should help him to get something and bring it. And I'll buy everything. And when I get there, he will tell me that, did I buy my own? I said, you didn't ask me to buy. He said, I cannot give you out of this one. The ATM is with you, so you can buy what you want anytime. But I will never touch his money. And when I gained admission, that was when he traveled abroad. And now, listen, because many of you misuse the opportunities. Now, at the end of the day, when he was traveling abroad, he gave me laptop and he gave me a modem. And he told me something that irinṣẹ́ motivate for him. And then Yahoo was the order of the day those days. Yahoo was 100% rampant those days. And when he got abroad, I told him, because he used to sponsor me a lot, so I told him that I've been given admission and all. And he said he would send me money for school fees, accommodation and all. Then our school fees was 20,000 thereabouts. Accommodation was, acceptance fee was also 20,000. But that was the time that they would tell me to preach for the first time in my church. And when I preached in my church, my pastor gave me 20,000. And the pastor asked me, and I said he just gave me admission and all. And he said, how much is my sentence? I said 20. And he gave me the money. But my bro is already abroad, so I already told him. And he knew he was going to send me money, and he sent me $200. And at the end of the day, I took this money. I went to, since someone else has paid for me, then after changing the money, $200 then was 30,000 naira. Yes, it was 150 naira per dollar, 100 naira per dollar. If someone sends you $200 now, that's like above 200 to 300,000. So please, that's not the purpose. Now, listen, I'm a family dollar, listen. So I now took 13,000 out of the money. I went to buy Nokia C3. And then I needed to be online because I was on campus and information and all. Then I downloaded WhatsApp. Then immediately saw my status. He said that, so that's your ending. That I should never ask him for anything again. And since then, no one naira again. But he said something. He said this laptop and modem is for your work. And I know what that means. But I carried the laptop. When I got to microbiology, they said, we are going to need Prescott's microbiology, it's like 18,000. We are going to need Alide physics. They told me a lot of textbooks we need to buy. I said, it was very well. I just went to download everything on the laptop. And I used that laptop all through. Thank God, baby, share on it. But I never used it for Yahoo. And I never used it for anything that would distract my life. And the phone was also to learn. It was not also to play and all of those things. At the end of the day, when my mates are now on break, I don't go home. I'm always on campus. I'll go and be teaching during the break. Then when I come back, I'll be the only one in the entire hostel. I know you used to have 24 hours electricity, but during break, they will off the entire lights. So I'll be in the hostel without lights. Everywhere will be dark. Nobody to sell water, nobody to sell anything. But I was ready for those. What I'll just do is that all my roommates' bed, I will carry everything and put it at the center, load them. So I'll be sleeping on top a very tall bed. Then I will carry my system. Then I used to watch animes. I will download several animes. Then I will go to Faculty of Education where they have lights. That was when I started working on all of those textbooks. Chemistry textbook, physics textbook, biology. I started working during the break. During December 25. If you don't understand what is going on for now, you don't get what is going on. Focus, learn. They have to come and collect phone from you like a baby. I pray God will help you. But there's a lot to this that you are doing more than all these classrooms. There's a lot for you to build and understand it. Please understand it. It costs me nothing. However it is, my own life continues. We can teach you if you pass. If you do not pass, it is still your cup of tea. We would have collected our own money. But my own purpose is to not see generation wasted. The way some of our own generation got wasted. We should not see you get wasted. That's what I'm saying. And thank God. I've forgotten your name. The two people I'm talking about, that's the brother of one of them. I'm sorry I'm pointing at you, but that's the brother. His sister is Islamiat, and Azizat Abi. Azizat is the elder sister. Then the two girls, Islamiat and Azizat. Ask how they read and how they fought her. Islamiat is a 400 level medicine now. Azizat should also be a 400 level civil engineering. And they are doing well. But once year, after the same 5 years, táwọn yẹn ti lọ, ìwọ ṣẹ̀ṣẹ̀ wá fa ọmọ kan dání, ó fẹ́ lọ register for JAMB. kilo share to fair register for JAMB register. And then mo bó ṣe serious nígbà ọ̀tọ̀ ní kò tiẹ̀ wá serious kí wọ́n máa work out. Àmọ́ bó ṣe serious. A dẹ̀ ń sọ náà ẹ̀ gbọ́. Náà á ti wá pẹ́. Kẹ́ńtọ̀ pé ẹni ẹ̀ tẹ̀ ṣe ronú pé òun sì fẹ́ ṣe nǹkan tó yẹ kó ṣe. Some people will lose it totally and they will now be ashamed. I used to say something that if you come to climax and in the next 10 years, we probably see you carrying tray of vegetable with 2 children and orin kiri gbolo kiri. Iṣẹ́ ló ṣe o, iṣẹ́ ló ṣe o. It's nothing. You can do it, but you can choose a life. You can choose. Do you think that most of those women tó máa gbálẹ̀ láti Sango délé ẹlé iṣẹ́ rò kó ń dùn mọ́ wọn ni? But they just want to survive at this point in time. Don't let it get to a state that survival is the only thing you have. You have no options again. Do you know that some people don't have option again? The only thing they just have is survival, and they cannot steal. So they have to survive, and that's where the problem is. Even if they employ me as someone that will sweep from LA to Sango, I will also employ people. I will employ people. From my salary, I will pay people salary, and I might not get to work, and the work will always be neat every day. Cover respect. Pé ṣé bá gbà ẹ́ kó gbájú láti Sango, ṣé kò mọ̀? Ó mọ̀. I'm educated. I can employ like 100 people. They will sweep it in like 1 hour, and in that 1 hour, ẹgbàá 2k, urgent 2k, ẹgbàá. And everywhere is clean. And èmi náà lè má rí ju 2k lọ, but tí bá ṣe níbí báyìí tí mo ṣe níbẹ̀. Before you know it, my education is helping me. And when my supervisors come and say, sir, if you want this to be done with proper iniquity, this and that. So, plus 1, minus 2, plus 1. What would this one be? Plus 6. This is plus 6, so not minus 2. I had someone say minus 2. This is minus 2. This is what? This is what? This is what? This is what? So the moment you determine all of these things, which question are you asking? How is it plus 6? Do you know we got plus 6 yesterday? Yes. From the calculation, Abi, this is going to be 2 into 1 plus x, Abi, plus 4 into minus 2 equals 0, Abi. So that's going to be 2 plus x minus 8 equals 0. X is going to be 8 minus 2, and that's 6. Do you get that? But we already said something that everywhere you see hydrogen, it is always what? Plus 1. Everywhere you see group 1, it is always what? Plus 1. We said that yesterday. So if you look at this, is this a redox reaction? Eh? No. It is not. Why is it not a redox reaction? Nothing changed. Abi? Sodium here is plus 1. Sodium here is also what? Plus 1. Sulfur, oxygen here is minus 2. Oxygen here is minus 2. Oxygen here. Do you get that? Nothing changed. But look at this. Is this a redox? So check, is this a redox? Is this a redox? So check them out. So please, I beg in the name of God, do everything to help your life. Please. Do everything. There's nothing you can do aside education. You can be a businesswoman, you can sell vegetable. If I'm selling vegetable now, it will be different from every other person. You can sell it. But add education to it and you will see how far your vegetable will go. You will see how far your pepper will go. So, what do we have here? This is 0, Abi. Yes. What's this one? Hydrogen. Nitrogen. You can calculate that. You know nitrogen can have minus 3, can have plus 5. So you have to calculate it. But if you look at it, 3 times minus 2, that's minus 6. Minus 6 plus 1, minus 5. So that means it's plus 5. You can calculate that. This is plus 5. Is that taken? This is what? Minus 2. This is what? This is plus 2. This is like saying CU2 plus and NO3. Sure you get. But you can also calculate it. But that's plus 2. Nitrogen here is still. Oxygen here is. Hydrogen here is. Oxygen here is. Nitrogen here is. That's why it is called nitrogen 1 oxide. So this is your laughing gas. Note that. And a lot of people used to make this mistake. Laughing gas is called nitrogen 1 oxide. But because of these two, some people used to take it for nitrogen 2 oxide. Nitrogen 2 oxide is NO. But this is nitrogen 1 oxide. Please note that. So the formula is N2O. And that is called laughing gas. That's by the way. So now, that means that this nitrogen here is what? Oxygen is what? So is this a redox reaction? Yes, because when you check, nitrogen is plus 5, but from here, it becomes plus 1. That means something has changed. So anytime you see a change at all, then that means, if they now say that calculates the change in oxidation of nitrogen, that means we are going to say final oxidation of nitrogen minus initial oxidation of nitrogen. And the final oxidation here is 1, Abby. So that's 1 minus 5, Abby. And that's going to be minus 4. They can ask you questions like that. So is this a redox? The first one? Eh? This is plus 2, Abby. What's this one? What's carbon? Eh? Plus 4. Abby, what's this one? So is it a redox reaction? Because there is no change in oxidation state. So now the question is, which one is undergoing oxidation and which one is undergoing reduction? Which one is the reducing agent? Which one is the oxidizing agent? So this is not a redox. This guy is not a redox. So let's look at this one. Which one is undergoing oxidation? Zinc. Because it goes from 0 to what? And that's what we call increase in oxidation number. Abby? So at the end of the day, this one is undergoing oxidation. This one is undergoing. If they now ask you, they can just give you an equation and ask you, which one is the oxidizing agent? CuO. The one that undergoes reduction is the oxidizing agent. Let me rub this one first. So this guy is undergoing reduction and it is called the oxidizing agent. This one is undergoing oxidation and it is called reducing agent. Is that taken? So looking at these two guys now, why do we call this one oxidizing agent? It's because without this one cannot undergo oxidation. So this is an agent that brings about oxidation of this guy. So an oxidizing agent is that species that brings about the oxidation of another species. It's an agent that allows this one to undergo oxidation. This one is the one that allows this one to undergo reduction. Without this one will not undergo reduction. And without this one will not undergo oxidation. Is that okay? Which one is the reducing agent here? Which one is the reducing agent here? I told you something that whenever you are picking your answers, don't pick here. Anything on the product side, you neglect it. Abby, you always pick your answer from this side. Abby, so which one is undergoing oxidation here? copper B is undergoing oxidation because it's going from 0 to. You can see nitrogen here going from +5 to +1. That's reduction. So this guy is undergoing reduction. This guy is undergoing oxidation. So this guy is the what? Reducing agents. Why this guy is the what? Oxidizing agent. Do you understand it now? So this concept is very important. So now that you understand this, the next thing to talk about is redox equation. So let me give you a quick question. Determine the reducing agents and oxidizing agents in the following. So determine the reducing agents and the oxidizing agents in the following. 1. HCl plus, let me say 2S. So from the three reactions, determine the reducing agent, the oxidizing agent, the one undergoing oxidation and the one undergoing reduction. So that's your job. Let me quickly look at your gathered paper. If you are writing paper now, be writing your name. Because there are some questions that, sir, for the change in oxidation state that was calculated, it should be 1, not -4. We should probably recheck. Okay, thank you. Let's recheck. What's this one? Is this one 1? Is the oxidation state of this one? One Abi. Calculate it now. You will know if it is 1. This is going to be 2x minus 2 equals 0. Abi. 2x is equal to 2. X is equal to 2. And that's 1. Abi. So now, this one here is what? +5. Abi. So if they say calculate change in oxidation state, that's final oxidation state of nitrogen minus initial. The final is what? Abi. And the initial is what? So what's our answer supposed to be? -4. Oh yeah, you that you said the question, come and tell us why your answer is 1. No. So is the answer -4? Eh? Yes, now, so I don't know who said that question. So it's an observation. If you feel like we have done something wrong, go here talk now. We might be blind to it. They see you. No, we are not doing for here. Nitrogen here still remains. Is it +5 here? No, you are not adding it. You are not going to add this to this. This one did not change, so it has nothing to do with it. Yes, it's just more than they said change in. So it changed from +5 here to +1 here. That's what we have done. So if you check this out, this is going to be +2, +1, +4. Right? is not a redox reaction. Is that taking? Next question. Stoichiometry. I think I'll solve this one. This question, that is on 2% molar H2SO1. Should you give them that formula? But it's not complete. Yes, question 1. It's not complete. That question 1 is stoichiometry. That formula is molarity is equal to that's 10 over 10. So to calculate concentration, they will give you the percentage of that compound. This is stoichiometry now. Give you the density of that substance and give you the molar mass. They can calculate concentration. This one is called, this P is called percentage purity. D is density. And then is molar mass. So the second question says that, sir, the oxidation state of S in S2O3. S2O3. What's the oxidation state of this guy? That's going to be 2x plus 3 into minus 2 equals minus 1. Happy? So that's going to be 2x minus 6 equals minus 1. 2x equals minus 1 plus 6. 2x is equal to plus 5. And 3x is equal to 5. And I told you that you don't always have fractions. But because I only gave you some of those things off hand. I don't know what question this is, but let me answer you. H2 plus 2Fe2 plus Cl2 2Fe. You can't have H2O here and have H2O here. It's not possible. You cancel out. So, but let's look at this. And there's a mistake in that equation. This one cannot be plus 2 here and still be plus 2 here. Why this one change? So when this one was losing, gaining electron, where did it gain it from? It must have gained it from iron. So this one must have been plus 3, not plus 2. So in this equation now, which one is undergoing oxidation? Iron. It's going from plus 2 to what? To plus 3. Abby? So this one is undergoing oxidation. And it is reducing the agent. This one is undergoing This one is 0 and it's minus 1. 0 to minus 1. Is there any increase or decrease? It's a decrease. 0 to minus 1 to minus 2 to minus 3. That's decrease now. Abby? So this one is undergoing reduction. This one is undergoing oxidation. Is that taking? Please, 3 plus 2Fe, that's plus 3 to 0, that's reduction. So is there any other question? Is Mr. Felix around? Oh yeah, what are the answers to this question so I can move out? H2S is what? Reducing agents. This one is This can be +2 and this is +2. So that place the main mistake. It's like so far this one has changed, this one changed, this one changed, then this one cannot remain the same. This one lost electron, it gains electron. When did it gain the electron from? It was separated from this one. And if this one loses electron, oxidation number will increase. So it's going to I've answered this question here. So, we see tomorrow.